What happens when you connect a preamplifier up to a power amplifier via the same power supply rails without any bypassing? Oscillator. Greetings, the Astro 30 here. Welcome to part 5 and the final part of this mixer preamp project. Now, I've gone ahead and I've routed the PCB in Proteus, and I'm not going to go through it too great of detail here, but we've got all 4 op amps in a line, and usually when I'm routing out a PCB with op amps anyway, I usually start with the op amp and work components around it. Now, I don't use auto routing of any PCB feature, PCB package, because, well, I'm old school and I used to use Proteus Easy Tracks, which I believe back then didn't have an auto routing feature. I don't even think it had a schematic feature, to be honest. So you had to route everything manually, and there's nothing wrong with routing it manually. You've got more control over where to place components. However, auto route does have the advantage of placing all the components on the board that you need, and you just move them around so that the routing will work. The other issue with that is you need a net list in order to make auto route work, and considering my schematics drawn in KiCad, and trying to generate a net list in that is a pain in the ass. That's not going to happen. So I still always do my PCBs by hand manually. I guess it's just a personalised touch. Anyhow, over here we've got the power supply input plus minus 15 volt. There's the mixer input up there from the previous board. 2 bulk filter capacitors. The summing amplifier on this side. On this side is the equalizer backs handle amplifier with the bass mid treble controls here. Next stage features the preamplifier output buffer using the NE5534. There's a 22 picofarad capacitor here across pins 8 and 5, just to help to keep the op amp stable. This side here is the balanced driver for the hot and cold pins respectively, and over here is our normal line outside and our headphone amplifier down here on the other side of the op amp. Now there's this line drawn here between a pad on the PCB and dots on top of each pot. That's to indicate the tin copper wire that is going across the tops of our bodies of our potentiometers to ground the body. So call that a body ground if you like, but to ground the body of the rewind, insert brain. To ground the bodies of the potentiometers. Now this is the complete schematic. Over here is our input stages, but we've already seen that. Now this is our entire schematic: summing amplifier, backs handle, line out driver, preamp out buffer, balanced line driver, and the headphone amplifier. So our summing amplifier over here, our bass, mid-range and treble, a backs handle circuit here which is active, master volume there, the NE5534 output buffer, the line out driver which all comes off before the master volume control, and our headphone amplifier down here with its own separate level control. Just we've seen this a few times, it's not that exciting. And over there is the normal line out buffer and the power supply filtration. Now we've got a 2 100 microfarad bulk filtering, which we saw at the far right hand side, left hand side of the board. And each of these 100 nanofarads, like usual, go close to the body of each IC. So this one goes close to U1, U2, U3, U4, etc. So that's the complete schematic. I will upload that later and put a link in the description for that schematic so you can see it in complete format. And finally, here is a rough draft of my PCB artwork minus the copper fill, which is the ground planing and filling in with spaces with copper here. I just printed it out like this. This was after I did the basic route, just so I could change the colour of this to grey, re-import my components on top, and then check that it was routed correctly by going through it. It's too hard to, with a black and white printer, to print the copper out in black and the components out in black and then try to trace out all the traces where they go with the components, because it's too hard to read. Obviously, if it was a colour printer, it wouldn't matter so much. You'd print the components in black and the copper in, I don't know, red or something. Anyhow, so that's my layout. I did do another one before this and realised that for some stupid reason I ended up with 25mm between each pot and 30mm between here and the headphone jack. Not sure what I was smoking when I did that, but yeah, I ended up, it was actually only about this big originally. I thought, oh yeah, great, that'll fit on a nice piece of 150 by 110. No, that's because these measurements are wrong. I now have to use a larger sheet. But that's no real great big of a deal there, but yeah, I should have printed this out first and made sure that the measurements were correct before doing all the routing, because I then had to start dragging stuff across just to make it work. But anyhow, that's our basic copper artwork, we'll call it. So the final one has all the fills in it, as I said, and so the next stage now is to spend the next 2 or 3 hours, because there's a shitload of holes to drill, is exposing the pattern onto a piece of PCB, developing it, etching it, and drilling it, cutting it, cleaning it, and protecting it, etc., and then come to assembly. So today I will be doing that, and when I've finished that step we'll come back again like I did in the last video and we'll start assembly of the PCB. And there it is there. Turned out quite well. It's upside down to the camera. There we go, it's right way up now. Yeah, it turned out quite well. Not all the resist came off when I cleaned it, so it wasn't cleaned perfectly well. But it's all drilled, sized up to where I need to be for hole sizes. And yeah, it's ready for assembly now. Got all my bunch of parts laid out on the side here. I thought it'd be easier just to, you know, write down the value of resistance that was sitting there, so it's easy just to pick up without having to look at it. I've already spent the time and read the values. I've got the schematic sitting there as well, not that I need it, but so it's ready for assembly. All I've got to do is put it in its little jig thing tool to hold it, and then I can start assembling it. I'm going to start assembly as usual with things like link wires, IC sockets, plug connectors, etc., and then move on to resistors. Still a bit bright. Yeah. Move on to resistors, then finally capacitors. So I'm going to do all that in time lapse because you guys, I don't know, I think some of you actually like seeing that. Okay, that's assembled. Only took me about an hour and 40 minutes, not that long. I forgot to drill 3 holes. One where this 22 picofarad capacitor is, and one on this 100 nanofarad down here. Now you may have noticed that I was digging around with a drill bit in the time lapse there and wasn't getting very far with drilling a hole until I changed it to another one that I had, which is a bit of better quality one, and it was sharper and went straight through in 5 seconds. It's proving to me that that 0.8mm drill bit that I use for drilling all my circuit boards is now blunt. Other thing is, I drilled one of these holes off on this connector, and that's why you would have seen me with a pair of pliers bending the connector around a bit just to make it look straight even though the holes are off. Right, so the next stage before testing would be to put the potentiometers in the holes, but I've got to prep them like I did in the last video. That spile off a little bit so I can solder my link wire to each pot. I'll do that off camera. I already did it in the last video. There's no point rehashing something that's already done. So I've also got to make up a connector for the mix board out to here, and also for the preamp out into a long lead so it can be connected to a power amplifier. These two are irrelevant. I can just stick oscilloscope probes on that just to measure to make sure there's a signal there. No big deal. So I'll get to doing that. I'll mark my polarity of this connector, and just out of interest here, you may notice that I've made it so that the two connection points for the 15-volt rail are actually on the same side. Isn't that special? That was done on purpose. Right, so I'll get to doing the pots, doing these sodding 2 cables, which are always a pain in my fucking ass, and then we'll come back when we've got something ready to go to test. Okay, it's almost ready for testing. I've done the potentiometers, the grounding strap. I've put some leads in for the power into the connector here to make it easy to connect. Marked the positive and negative connections, not that it can be seen very well. Put some knobs on. I've gone for 3 blue for the bass, mid, treb, red for the master, and yellow for the headphone volume. And on the other board I went with all green for the inputs, noise. So yeah, I've got to make up a connector for this end so I can connect to here, and also the connector to come from the preamp out. So I'll get to doing that, and we will come back when we are complete with that stage. Right. Now, did I mention I hate these sodding connectors? I think I did, probably several hundred times. Okay, now what I'm going to do is I'm not going to connect the input board up. I'm going to connect this board up to the power supply, connect the output here to an oscilloscope, and we're going to look at whether we get inject a signal into here, which I can't do now because I've already crimped my cable. But what I could do is I could just, use an oscilloscope probe just to get an input into it. I've got no other easy way of doing it, or, well, however, could probably just borrow one of these sockets off the input board here, because the grounds are all in the same place, so, and then just hook it up to a plug just to get it to work. So okay, let's pop you on the floor and I'll set up my oscilloscope and other test gear and we'll get going. Okay, I got everything set up. When I was connected to this lead, there seems to be a lot of noise being picked up on the oscilloscope, so I'm just wondering if the end of this cable's crimped correctly. So I've connected it directly to the socket and there's no noise. So I'll look at turning the power on. You can see a little bit of noise on the scope there. Increase the master volume. That's the wrong volume control, by the way. Increase the master. Well, okay, that's unexpected. So let's turn our amplitude down to 1 volt. Well, that's annoying. It should not be square. Oh dear. So I don't know what's going on here, but that is an epic fail so far. Very epic fail. I'm not impressed. Unless it's my probe. Hang on. Could be because I'm on ×1. No, it's got nothing to do with that. So we'll take it to 500 millivolt. And it's still square. That's not great. We're in continuous wave. Mirror and sweep, so a continuous wave. So I don't know what's going on here, but it should not look like that, that's for sure. Just checking other things here, they're not getting too hot. Well, that's at the output buffer, so let me take my probe and do it before we go anywhere near the volume control, which is off this 100 ohm. Well, that's interesting there. So it's square there. What about the output of the headphone amplifier? Also square. So for some reason, let's have a look at what's coming off of the summing amp, which is pin 7. Okay, so the summing amp appears to be causing the problem here. The input is there. That's my DDS input, which is not very great. So amplitude 1.5 volt. Oh, for God's sake, 1.5 volt. Yeah, I can see that the input's okay. The output is shocking. Righto. Unless there's something wrong with that NE5532, so let me just change the op amp and see what happens. Okay, I've changed the input op amp. Just got to find my probe. I'm going to turn the load back on and probe the output again. No, it's still doing it. So there is something not right in the circuit here. Because it shouldn't be coming out square like that. So I'm just going to have a quick look at my overlay diagram and see what I've done wrong here. Alright, nothing is wired wrong, but I turned the DDS down to about 100 millivolt because, don't forget, we're going through a 47k resistor first before going into the summing amplifier. So the gain is not actually being set correctly on this op amp because we don't have an input resistor. So now somehow I have to connect a 47k to the input just to test this. So give me 2 seconds. Okay, got a 45k resistor, a 47k resistor rather, jammed in the connector. Connected to the input of the board. So now if I turn my power back on and then find out where the other probe went, and now carefully just sort of untangle this, probe our output of our op amp without shorting anything. Now I can't see bugger all. So I'm going to turn my amplitude back up to a volt. There we go, we've now got a nice sine wave. Now if I take this off times 10, there we go, that looks a little bit better, doesn't it? Right, so just for reference, the input resistor at the op amp before the feedback resistor on the same pin does actually help to be in circuit. So now I'm seeing what I'm supposed to be seeing, and I'm pushing out 3.2 volt out of the op amp, which is about right. 1 volt in, 3.2 out. It's a gain of 3.2. So I'll have a look at it at the output of the back sandal, which is pin 1, and we've got exactly the same signal. And I haven't seen a phase shift because we won't. Okay, now I'll connect back to the output. So I'll connect my output cable and just check that my output cable is actually functioning, or if I have to recrimp it. So I'll connect to there. Now I don't see anything. I see absolutely nothing at all. So I think I might have to recrimp that cable because I lost my ground. If I carefully connect my probe back up to, oh, if I can, it'd be nice. Sometime today it'd be nice. Yeah, now we've got an output. And we're driving into distortion. So we're actually pushing out, if I back that off, and go into times 10. No, we're not actually distorting. We're pushing out 13 volt, 13.8 volt at the master, which is pretty significant. Okay, now to have a look at the signal at the headphone amplifier now. I knew it was working because we just tested it before, but it was crap. We have a signal with the, well, we did. Right, with the volume control half mast for the headphones, we're getting on a times 1 probe of 1.5 volt. Now we're clipping, and we're not clipping, so we're pushing out 18.1 volt into the headphones. So I know that the headphone amplifier is working. Now to look at the line out, we have a signal. It says it's about 345 millivolts thereabouts. Helps to be on times 1. 2.9, that's okay. The cold pin is pushing out 3 volt. The hot pin on the balanced is pushing out 3 volt. No, 2.9, a little bit different. So I know that the outputs are functioning. This cable is not. I'll investigate that in 2 seconds. And the preliminary tests show that the board is functioning. Haven't gone into testing the back sandal circuit yet, but I know the headphone amplifier is working. The main output is working. It's not going into oscillation when I rotate the control all the way up. The line outs are working. I don't know if they're out of phase with each other as they're supposed to be on the hot and the cold. We'll have a look at that shortly. What I'm going to do now is I'm going to investigate this cable first, and then we'll get into some proper testing of the back sandal circuit, frequency response, and then I'll connect the 2 boards up, and then we'll do a complete maximum output voltage before clipping of this little preamp. So, moving on. Just went to take a break and looked outside. Ooh, it's all foggy. Nice. It's raining today. It was supposed to get to 24 and it was supposed to be muggy. Well, that didn't happen. It's probably about 16. Yeah, it's fairly foggy at the moment. I'm really going to miss this house. I'm also going to miss my room, my lab. Oh well, shit happens. Figured out what was wrong with this connector. It wasn't a continuity problem. I had the bloody wires in the wrong spots. So I'd actually had the ground going to the signal and the signal going to ground, which is why I was not seeing anything on the cable. Right, so now I'll turn the power supply back on. Increase the master volume. We've got random noise, but we are seeing a signal. Isn't that interesting? Okay, so I'll put that up to my normal probe, which is times 1, and we can see that, yeah, it's doing what it's supposed to do. Okay, so I'll leave that about half mast. I'll play with my treble control, and there is a slight increase at 1 kilohertz and a slight decrease at 1 kilohertz. Mid-range, we do actually get a big increase and big decrease at 1 kilohertz, so the center frequency of the mid-range is around 1 kilohertz, and the bass hardly moves at all. Beauty. So the back sandal circuit is working correctly as it should. So I guess we can do a frequency sweep and see what we get. Here we go. So I can't really see much, so I might change that back to 1 millisecond. And I'm just looking to see if the frequency response remains around about the same voltage. It starts off at 2 at the low end, peak to peak. Starts dropping off now. I'm not sure what frequency we're at. We're at 11 kilohertz now, 12 kilohertz, and it's dropped down to 1.8 volt, 1.7 by 16. So it is slowly rolling off a little, but not too significantly. Alright. And so now what we're looking at is we're looking at the balanced output, and the green trace is the cold, the yellow trace is the hot, and as we can see it is indeed 180 degrees out of phase, which is exactly what it's supposed to be, because if I now remove the probe off the cold and stick it on the hot, it's the same way around. So I know that it's inverting, and so that balanced output is working correctly. I can't get the sodding thing back on the connector. There we go. So we've tested the frequency response, we've tested the overall performance of the unit, we'll say, and every output is outputting as it should, and the controls are all making adjustments to things as they should. Now the next thing is to connect the main board back up to this board, and I'll go on the line input 2 volt channel and just see how much output voltage we get peak to peak out of the thing. So that's the next stage I'm going to be doing. Okay, got both boards connected to the power supply and each other. The DDS input's now moved to the line input connection. Output's back on the preamp out, so we'll turn on the load. We do have a bunch of noise there for some reason, so increase the volume of the line input. Okay, so go back into times 10. Let's see. Okay, so we're maxed out on the line input volume pot. We've got 2 volt peak to peak coming in. Just going to change this back to a times 10 setting so I can read the voltage measurement correctly. Apparently 10 odd volt peak to peak, and that's with the master half mast. So I'll start rotating that up. Oh, we're clipping. That was my meter. I forgot I didn't turn it off. So we're at clipping point just before there, and we're getting, whoa, a healthy 31.6 odd volt, yeah, 31.3 volt peak to peak out. That's significantly loud, so that'll drive any power amplifier into distortion quite easily. So the actual amplifier, preamplifier module itself should have plenty of headroom on the controls. So the next thing to do would be to play with my penis. No, I've already done that. No, I actually haven't done that today. You guys didn't need to know that. Is to remove the oscilloscope now and actually hook it up to a source of sound and to a power amplifier. I think I'm going to use the LM3875 today. But before I do that, I don't want to run that at 15 volt. I want to run it at 30 volt off the power supply. So what I'm going to do is, on a bit of breadboard, I'm going to put 2 15 volt regulators, both plus and minus, so that I can put the 30 volt plus minus into the regulators and then put the plus minus 15 out into the circuit boards here, and then the full 30 plus minus goes straight into the power amplifier. So the power amplifier will be operating around where it needs to be. So that's going to be fun. So that's my next step. Okay, got the little, I was going to say op amp, that'd be incorrect. The little regulator circuit built up on the breadboard here. They were a prick to get in there. They're going to be a bigger prick to pull back out. I've got the multimeter's negative probe connected directly to the ground point of both here. Power supply is still at 15 volt, so that's where I'm going to start at. You're not going to see much in the way of output regulation at that voltage because the reverse input voltage is incorrect. It needs to be about 2 volt higher than the output. So, or the expected output. So I need to move this around so I can move my probe. Now I'm going to turn it on. Nothing went off with a bang, which is always good. So I'll test the negative side first. We're getting negative 14.5 volts. Brilliant. Now I'll test the positive side. More like 16. Okay, so I'm going to increase my voltage up to about 20. Right, that's telling me that the input and outputs to the positive side regulator are back to front, so I need to correct for that. Let's try that again. So now we have an output of 1 volt. Okay, so that's not right either. So, and that regulator was getting red hot, so that was not correct. The gripping entertainment just changed the regulator because I blew it up. It might have been a dud regulator anyway, so let's connect to the output and I'll turn the load on. Well, we've got no output voltage, so that's because that's not even connected where it should be. That should be connected to there. Let's try that again. That's better. We got 14 volt there positive and negative 14 volt there, so there must have been something wrong with this regulator. It does say it is an L7815CV, which is the same as what I've just inserted. I reckon this came out of a kit somewhere. Buggers if I know where I got it from. But that one doesn't work. So with the load still on, just making sure that they're not getting hot. Okay, so I know that the regulator is working and I'm going to get a proper, excuse me, positive 15 volt out. It's more like 15 now. And minus 15 out. So, being stable like that, I can safely connect it to the preamp and not blow anything up. And I can also connect it up to a power amp. In fact, actually, I'm going to take the voltage on my power supply all the way up to 30 volt. And we're still regulating at 15. And still regulating at minus 14.8. Which is exactly how it should be. Just make sure they're not getting hot, which they're not. Okay, now I can hook up a power amplifier to the supplier's output here, and the preamplifier's leads here can go to the breadboard circuit. And yeah, as long as nothing shorts on that breadboard. As messy as that all looks, so I've got everything hooked up. Speaker, the input's just screwed into the terminals here. Might move that over just a smidge. Now, first thing I'm going to do is turn it on, see if there's any strange noises. Well, there's a bit of a hum there. That's coming off the preamp, and I've got that up full, and it's not oscillating, which is good. Now, I need to plug in an input, don't I? That might help. So, I'll plug in my guitar lead around the desk. And I might just shove a pair of pliers on that and stop pulling on it. Okay. I'll turn up the... Okay, there's a bit of buzz there. Okay. bass, bass, mid-range, yep, treble, beauty. So I'll turn that input level down. It's only because the preamp's in close proximity to the power supply and all this shit's all over the place. Just doing a heat test on these, make sure it's not getting overly hot. It isn't, but the final design will need heat sinking, just saying. But at the moment it's fine. So with the power amp operating on its full power, or close to it, so where am I there? Not even halfway yet. Now I'm halfway. Certainly speaking pretty loud, so I might drop the bass so I don't kill the speaker. I've got an issue here somewhere. Socket on my bass. Seems alright. So, do I have enough room to sit down with the lead all the way over there? Let's find out. Yes, I do. Yeah, anyway, seems to be working quite nicely. Albeit the volume controls are half white. But it certainly does have plenty of gain, so. Okay, so I know that the thing is actually working, and the reason we were seeing so much noise on the oscilloscope before with the input stage connected is because the other high gain inputs weren't grounded at the input, so we were picking up random noise on those channels. So next I'm going to plug in a pair of headphones, I guess, and make sure that the headphone amplifier is sounding okay and driving both channels correctly. We're not drawing too much excessive current, by the way, just thought I'd share that. Plug this in, turn up its volume. Turn the master down. I can hear it, but there might not be quite enough gain on the headphone amplifier. Although I suppose, even with it up full, that's acceptable, because then you're only just worrying about your input level. So as a monitor, yeah, that's about right. So I know that the headphones work, and work pretty well. I'll plug them now. And yes, I do still play the Casino 4-string bass there. It's a nice bass, it's pretty light too. The one I built is pretty heavy. So I think all that effort I put in over the last couple of days making the layout and shit, and then spending all day today making the board, even though, yeah, they're getting pretty hot. I have to put heat sinks on them, but they're not red hot, so I've got to keep that in mind. So for now I'm just going to turn it off. And albeit that I forgot to drill 3 holes, which is something I always tend to end up doing, I think it's time to celebrate. Cheers. Nice. Well, I'm going to end this video here. In a later video we're looking at this mixer preamp again, but I'm going to save what I'm going to be doing with it till a little bit later. But for now I'm going to end this video here, so if you enjoyed it, please remember to comment, rate and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyway, thanks for watching, and this is the Astro 30 saying, happy mixing. See you later.